Dear students, today we are going to start the reduction formula. You know the integration of sin x. It is nothing but minus cos x. Suppose I want to find integration of sin square x. So how to evaluate it? So I can write here 1 minus cos 2x by 2 means trigonometric formula, and I can evaluate it. Similarly, if suppose I want to find sin x cube dx, you know what is the formula for sin cube x, as sin 3 theta equal to 3 sin theta minus 4 sin cube theta, and by using that sin cube theta I can find out. You substitute here and we can evaluate. But suppose here I want to find sin x raised to 4, so I have to write again sin square theta into sin square theta, or maybe the x there, then whatever the variable. So 2 times I have to use this formula. So it is lengthy. It is a lengthy for sin x raised to 4 manually. Suppose sin x raised to 100, then how to evaluate? Sin x raised to 50, sin x raised to 30, then how to evaluate this? So it is lengthy process, and that is why need to find some reduction formulas about these. So what is meaning of reduction formula? If we consider in equal to integration sin x raised to n dx, means whatever the power of sine I am going to consider as a suffix. And if we are able to find the relation between in and in minus 1 or 2, means what is it? If we consider this, so it is nothing but sin x raised to n minus 2. So if we are able to find relation between these two, so it is nothing but a reduction formula. And if we have a formula there or reduction formula there, so directly we can find a numerical value or whatever the answer of that integral. If we have direct formula for this, then it is easy to find integration of sine any power of x. Is it? Even though one can write one program on it and then just put the value of n, whatever there, we will get the direct result there. So take one example or first reduction formula for sine. So sin x raised to n. So I am taking here in equal to integration sin x raised to n dx. So I will split it. How? So sin x raised to n minus 1 into sin x. So now by integration by parts. So integration by parts means integration of u into v. So what is that formula? As we know the formula, integration of uv dx equal to u into integration of v dx minus integration of u dash. Dash means here derivative. So derivative of u into integration of v into dx. So here you consider this is your u and this is your v. So I am getting here by integration by parts, first constant means u constant. So sin x raised to n minus 1 into integration of v means here sin x. So what is the integration of sin x? It is a minus cos x minus integration of, in bracket, derivative of first. So what is the derivative of u? Means here sin x raised to n minus 1. It is nothing but n minus 1 into sin x raised to n minus 2 into cos x. It is the derivative of sin x raised to n minus 1 into, now integration of sin x, that is a v. It is nothing but minus cos x, bracket close dx. So simplify this. So I am getting here minus sin x raised to n minus 1 into cos x. You take constant term outside. So this minus sign and this n minus 1 outside. So I am getting here plus n minus 1 integration sin x raised to n minus 2 into cos x into cos x. So cos square x dx. As we know, sin square theta plus cos square theta equal to 1, and that is why here cos square x I can write it is as 1 minus sin square. So therefore I am getting in equal to, in bracket, minus sin x raised to n minus 1 into cos x plus n minus 1, here integration sin x raised to n minus 2, and this cos square x I can write now 1 minus sin square x dx. Now multiply this sin x raised to n minus 2 inside. So I am getting here So first term as it is, that is a minus sine x raised to n minus 1 into cos x plus n minus 1 sine x raised to n minus 2 into 1. So I am getting sine x raised to n minus 2 minus sine x raised to n minus 2 into sine square x. So power n minus 2 plus 2. So I am getting power n. So here sine x raised to n dx. Now separate the integrals. So I am getting here in equal to minus sine x raised to n minus 1 into cos x plus n minus 1. Now in bracket integration sine x raised to n minus 2 dx minus integration sine x raised to n dx. As we know, in means what? What is the in here? Whatever the power of sine is nothing but suffix of I. So that is why here I am getting this is nothing but in minus 2 and this is in, and therefore in equal to minus sine x raised to n minus 1 into cos x plus n minus 1 in bracket. I am getting now here in minus 2 minus in. If we multiply this n minus 1 inside, so I am getting here this remaining as it is n minus 1 into in minus 2 minus n minus 1 into in. So this minus n minus 1 in you take left hand side. So I am getting here in plus n minus 1 in, and that is equal to minus sine x raised to n minus 1 into cos x plus n minus 1 into in minus 2. So if we simplify this, so here in common, and in bracket I am getting 1 plus n minus 1 into in, and that is nothing but sine x raised to n minus 1 into cos x plus n minus 1 in minus 2. So what is the in then? So I am getting here n into in, the right hand side as it is. So now I want to find in. So divide throughout by n. So I am getting in equal to minus sine x raised to n minus 1 into cos x upon n plus n minus 1 upon n into in minus 2. So this is the relation between in and in minus 2. Here power of sine is n, and here I am getting in result power of sine is n minus 2. So by using this again I will get n minus 4, then I am getting n minus 6. So I can reduce it, is it? And that is why it is a reduction formula for sine. Now by using this result, if suppose I am going to put here the limit, means for the definite integral, the reduction formula means I am getting here the numerical value. So how? Suppose I want to find the reduction formula for sine x raised to n, but now here the limits 0 to pi by 2. Note that here n is any positive integer. So if I am going to consider again here in equal to integration 0 to pi by 2 sine x raised to n dx. So we already have this formula. So same formula I will use here, but only limits are 0 to pi by 2. So that is why I am getting here minus sine x raised to n minus 1 into cos x upon n. Here limits 0 to pi by 2 plus n minus 1 upon n in minus 2. Note that for this also I am getting here power n minus 2 with the limits 0 to pi by 2. So substitute here upper limit minus lower limit. So as we know cos pi by 2 is 0, and that is why due to upper limit I am getting 0 minus as the sine 0 is 0, and that is why for the lower limit also I am getting 0 plus n minus 1 upon n in minus 2. Therefore, finally I am getting here in equal to n minus 1 upon n in minus 2. So if I am going to consider this is the one, equation number 1, or relation between in and in minus 2. So here if n here So I am getting n minus 1 upon n and in minus 2. So note that here again from the equation 1 I can write in equal to n minus 1 upon n in minus 2. For in minus 2 I will use same formula. So n minus 1 upon n as it is, and this formula, this n replaced by n minus 2. So I am getting here n minus 2 minus 1. So n minus 3 upon n minus 2 into n minus 4. Again use same formula for n minus 4. So I am getting n minus 1 upon n as it is, n minus 3 upon n minus 2 as it is, and for this n minus 4 means this n replaced by n minus 4. So I am getting here n minus 5 upon n minus 4 into n minus 6. So continue this. So I am getting here n minus 1 upon n into n minus 3 upon n minus 2 into n minus 5 upon n minus 4 into n minus 7 upon n minus 6. So finally I will get I0 or I1. It depends on this n, whether n is even or odd. How? For example, n is even, supposed to be 10. I will get here in minus 2. It means that here 8. I8. Then I6. Then I4. Then I2. And then finally I will get I0. Instead of that, if n is odd, supposed to be 11, then n minus 2 becomes now 9, then 7, then 5, then 3, then 1. So finally I am getting here I1. So that depends on n is even or odd, and that is why I am getting here result as in equal to. So I will write here n minus 1 into n minus 3 into n minus 5 into n minus 7 dot 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 upon n minus 2 n minus 4 n minus 6 dot 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 into I0 if n is even, and I am getting I equal to n minus 1 into n minus 3 into n minus 5 into n minus 7 dot 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 upon n into n minus 2 into n minus 4 into n minus 6 dot 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 into I1 if n is odd. Now what about I0 and I1? As we know, In means what? This n means power of this side, and that is why I can write here two values, that is I0 equal to integration 0 to pi by 2 sine x raised to 0 and I1 equal to integration 0 to pi by 2 sine x raised to 1. As we know sine x raised to 0, it is 1. So I am getting integration 0 to pi by 2 into dx. And what is the integration of dx? It is x 0 to pi by 2. Means limits are 0 to pi by 2. So upper limit minus lower limit. So I am getting here I0 equal to pi by 2. And what about I1? Here what is the integration of sine? It is a minus cos x integration. Limits are 0 to pi by 2. So minus outside. Upper limit means cos pi by 2. Minus lower limit means cos 0. As we know the standard values, that is the cos pi by 2 is 0 minus cos 0 is 1. So minus minus this plus. So I am getting plus 1. So what is the value of I1? It is a 1. It means that In equal to this value is same. Here I am getting pi by 2 and here I am getting 1. And that is why I can write here the result as In equal to n minus 1, n minus 3, n minus 5 dot 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 upon n minus 2, n minus 4 into n minus 6 dot 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 into. So here I am taking if n is even. So here what is the value of this if n is even? It is I0 and I0 is pi by 2. So I am getting here pi by 2. Note that here if n is even, Then n minus 1 is odd. So odd, odd, odd. So numerator contains odd. So finally I will get 1. And here I will get finally 2. Note the case. And if n is odd, then in equal to n minus 1 into n minus 3 into n minus 5 dot dot dot. Since n is odd now, here I am taking the n is odd, and that is why here odd minus 1, it is a even number. So these numbers are even. So finally I will get here 2 upon n, n minus 2, n minus 4, n minus 6 dot dot dot. Here I will get 1 into here I1, and I1 value is 1. So same result I can write as this one. Integration from 0 to pi by 2 sin x raised to n dx equal to n minus 1 into n minus 3 into n minus 5 dot 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 equal to 1 or 2. That depends on if n is even or odd. Upon n into n minus 2 into n minus 4 into n minus 6 dot 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 into 2 or 1 into k. So I will consider both cases together. So into k. So I am getting here k equal to pi by 2 if n is even and k equal to 1 if n is odd. Similarly, I can consider the reduction formula for integration cos x raised to n or integration from 0 to pi by 2 cos x raised to n. So here you consider directly. So you can observe here for the sine, the formula is n minus 1, n minus 3, n minus 5 dot 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 1 or 2. Here also the same. The same formula you will get for sine and cos. But when integration from 0 to pi by 2. One can prove by the property of definite integral. What is that property? Integration 0 to a f of x dx equal to integration 0 to a f of a minus x dx. And that is why integration 0 to pi by 2 sine x raised to n dx I can write as 0 to pi by 2 sine pi by 2 minus x raised to n dx by using this property. And we know by the trigonometric transformation, that is the pi by 2 minus x with sine, it is nothing but cos x raised to n dx. And that is why the reduction formula for integration 0 to pi by 2 cos x raised to n dx is the same as the reduction formula for integration 0 to pi by 2 sin x raised to n dx. Note the case. And that is why I make a list of reduction formula for sin x raised to n, cos x raised to n with the limit 0 to pi by 2. Also, there is a reduction formula for integration 0 to pi by 2 sin x raised to m cos x raised to n dx. So one by one we'll see. Here you note that is the reduction formula for integration sin x raised to n dx and integration from 0 to pi by 2 sin x raised to n dx where n is any positive integer. So remember here that is the integration of sin x raised to n dx equal to minus sin x raised to n minus 1 into cos x by n plus n minus 1 by n sin x raised to n minus 2. If we consider the limits here 0 to pi by 2, then we will get here direct formula, that is the integration from 0 to pi by 2 sin x raised to n dx equal to n minus 1, n minus 3, n minus 5 dot 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 1 or 2 whole divides n, n minus 2, n minus 4, n minus 6 dot 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 2 or 1 into k, where k equal to pi by 2 if n is even and equal to 1 if n is odd. So what is this formula? Let's see, very interesting there. Here power is n. So these are the numbers. Note that these are the numbers. So here n here. So n minus 1, then n minus 2, then n minus 3, then n minus 4, then n minus 5. So you can observe here the first whatever the power, you have to write the first number of denominator and then n minus 1 is the first number of numerator. After that, then you have to decide that is the next number as minus 2. So n minus 1 minus 2 I will get minus 3. So n minus 3 here, then again minus 2 I will get n minus 5, again minus 2, again minus 2. Finally I will get here 1 or 2, depends on n is even or odd. Then what about the denominator? First number is n, then minus 2, then minus 2, then minus 2 will consider up to 2 or 1 is the last number. Note that here this last number depends on n is even or odd into k. If n is even, then I will get here k equal to pi by 2. And if this n power n is odd, then I will get k equal to 1. So for example here, if we consider integration 0 to pi by 2 sine x raised to 4 dx. So by this formula, how to write it? Here 4 starting number, and then 4 minus 1 here starting number. After that, then 3 minus 2 I am getting 1. 4 minus 2 I am getting 2. So last number either 1 or 2, we have to stop this process into k. And what is the k? Here you can observe here power is 4, means it is a even. So that is why k equal to pi by 4. So I am getting here 3 pi by 16. If we consider the another example, integration 0 to pi by 2 sine theta or x raised to 10 dx equal to, here denominator starting number whatever the power, that is n here 10. Then numerator starting number is 9. Then minus 2. Then minus 2. Then minus 2. Then minus 2. So that is why in numerator I am getting 9, 7, 5, 3, 1. Either will get 1 or 2 last number. Then we have to stop this process. So here denominator 10. So what is the next number? Next number will be 8 minus 2. Then minus 2. Then again 6 minus 2 I am getting 4. Minus 2 I am getting 2. So this is the last number. And into k, power is 10, that is it is a even, that is why k equal to pi by 2. Simplify this by calculator, we can find this value. Consider another example. If suppose integration from 0 to pi by 2 sine x raised to 9 dx, then what we get here? So denominator starting number is 9, in numerator starting number is 8. So 8 minus 2 I am getting 6, minus 2 I am getting 4, minus 2 it is a 2. Then 9 minus 2 I am getting 7, minus 2 I am getting 5, again 5 minus 2 it is a 3, and 3 minus 2 it is a 1. And what about the k? Power is now odd, so into 1. So by calculator you can find the answer of this. Similarly you can find any power of sine if here the limits 0 to pi by 2. So similarly, we can consider the reduction formulas for the integration cos x raised to n dx and integration from 0 to pi by 2 cos x raised to n dx, where n is any positive integer. So integration of cos x raised to n dx equal to cos x raised to n minus 1 into sin x upon n plus n minus 1 upon n cos x raised to n minus 2. If we substitute here the limits from 0 to pi by 2, so I am getting the formula integration 0 to pi by 2 cos x raised to n dx equal to n minus 1, you can see there in numerator n minus 1, n minus 3 into n minus 5 dot 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 into 1 or 2 upon n into n minus 2 into n minus 4 into n minus 6 dot 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 2 or 1 into k, where again k equal to pi by 2 if n is even and equal to 1 if n is odd. You can observe that it is the same formula for sine and cos. So again the same thing I can consider, that is whatever the power, that number you consider in denominator first and minus 1 you consider in numerator. So first number once you get, then remainings, that is the minus 2, then minus 2 you consider up to I will get 1 or 2, which is your last number. So multiply or simplify it, value of k is depends on power of this cos x. If it is even, then I am getting pi by 2. If it is odd, then I am getting k equal to 1. So remember this formula also. So here the reduction formula for sine and cos, if we consider together, then So now consider the reduction formula for integration from 0 to pi by 2 sin x raised to m into cos x raised to n dx, where m and n are any positive integer. So what is that formula? So integration from 0 to pi by 2 sin x raised to m into cos x raised to n dx, that formula is this one. So here in denominator, first number I am going to consider addition of this powers of sine and cos. So m plus n. After that, then minus 2, then minus 2, then minus 2, up to the last number should be either 2 or 1. But in numerator, there are two different numbers we are going to consider. In the first bracket, I am going to consider the m minus 1. It is the starting number. Then again minus 2, minus 2, minus 2 up to 1 or 2. And second, in second bracket, this second power, that is a cos x raised to n. So I am going to consider the first integer is nothing but n minus 1. So first number is now here n minus 1. Then minus 2, minus 2, minus 2 up to either will get 1 or 2 into k. So what is this k? So here k equal to pi by 2 if m and n both are even. It means that powers of sine and cos, if both are even, then k equal to pi by 2. Otherwise it is 1. It means that other cases are if m is even, n is odd. If m is odd, n is even. And if both are odd, then in these cases we have to put k equal to 1. Now note that here we have the reduction formulas for sine, cos and multiplication of sine, cos. But when integration from 0 to pi by 2, but we can extend this by using some properties of the definite integral. Which are the properties? That is, you know the properties. That is the first property here, integration 0 to a f of x dx equal to integration from 0 to a f of a minus x. A minus x, note that here. Second property, integration from 0 to 2a f of x dx equal to integration from 0 to a f of x dx plus integration from 0 to a f of 2a minus x dx. So what is a half of this 2a? It is a. So here I am getting 0 to a, 0 to a, two integrals. But in second integral, it will be f of 2a minus x. It means that this x replaced by 2a minus x. And third property, that is the integration from minus a to a f of x dx equal to 2 into integration 0 to a f of x dx if f of x is even and equal to 0 if f of x is odd. So here you must know how to find even and odd function. So if f of x means that integrand function is even, so I am getting it is a 2 times 0 to a, integration 0 to a. And if the integrand function is odd, then I will get directly 0. By using these properties, we can extend our reduction formulas from 0 to pi by 2 to 0 to pi and 0 to 2 pi. So how? Let's see one by one. But before to that, you should know, actually these are the basic things what we are going to consider, but you must know it. Trigonometric transformations. So what is it? So trigonometric transformation, if we see these two figures here, so here it's a first quadrant, second quadrant, third quadrant, and it is a fourth quadrant. You know these things, right? In the first quadrant, if any, for example, sine 30, right? So it is in first quadrant. If sine 70 degree, so it is in first quadrant. If sine 120 degree, so it is in 90 plus something, it is in second quadrant. So like that. So by using these figures, we can transform the any trigonometric functions. So here, what is this? In the first quadrant, second quadrant, third quadrant and fourth quadrant. In the first quadrant, all positive means what? Sine, cos, tan, cosec, sec and cot, all positives here. In the second quadrant, sine positive. It means that sine and reciprocal of sine is cosec. So only sine and cosec positive, remaining all negative. In the third quadrant, tangent, or what is the reciprocal of tan? it is nothing but cot. So only tan and cot positive, remaining all negative. And in the fourth quadrant, cos and reciprocal of cos, that is nothing but sec, positive, remaining all negative. So how to use these figures? So let's consider one example. So for your understanding, note that here, when we are using this line, means 90 degree, or you can say pi by 2, here 270 degree or 3 pi by 2, then sine changes to cos and cos changes to sine, sec changes to cosec and cosec changes to sec, and tan changes to cot and cot changes to tan. But when we are using this line, means what? So actually consider one example. For example, here if we consider sine pi by 2 plus theta, so pi by 2, so pi by 2 means this, so I am using this line, plus theta. So plus theta means it is in second quadrant, and we know in second quadrant sine positive. So that is why I am getting here it is a positive, but here I am using this line, that is why sine changes to cos and I am getting cos theta. Pi by 2 plus theta, it is in second quadrant, I am getting directly cos theta. But suppose I am using here, I am taking here sine pi minus theta. So just observe. So pi minus, so where is pi here? So I am using this line now. So minus theta, minus means before that, it means that it is in second quadrant. Note that this is also in second quadrant, this is also in second quadrant, but here I am using pi by 2. So this line, and now I am using this line. Okay. So here it not changes. So that is why result will be sine. So it is in second quadrant, sine positive, that is why positive. Here I am using this line, that is why no change. So sine as it is, and I am getting theta. So be careful about this. If supposed to be tan pi plus theta, and one more, that is a tan pi minus theta. So what are the results? So tan pi plus theta, it is in third quadrant. Third quadrant tan positive. So it is very clear it is a positive. Now due to this pi, no change here. So that is why tan as it is, and I am getting tan theta. Pi minus theta, it is in second quadrant, and you know in second quadrant tan negative, and that is why it is first negative. Due to this line, no change here, and that is why tan as it is, and I am getting theta. Now you just observe from 0 to pi, this sine and cosec both positive, because sine positive in fourth quadrant as well as second quadrant. It means that 0 to pi sine always positive, also cosec always positive. But what about the remaining? If we consider the cos, then up to 0 to pi by 2 cos positive, but pi by 2 to pi it is a negative. And if we consider from 0 to 2 pi, so every, even though sine, cos, tan, cosec, sec and cot, all trigonometric functions are 2 times positive and 2 times negative. So very interesting. And that is why by using this transformation, we can extend our reduction formula from 0 to pi and 0 to 2 pi by using properties. So note here, integration from 0 to pi sin x raised to n dx. So if we convert this, we know by using a property, integration 0 to 2a. So I will split that 2a into 2 parts, that is the half of this. It is a 0 to a, 0 to a. But second I am going to consider here 2a minus x. So by using this property, I can split it 0 to pi by 2 and 0 to pi by 2. So 0 to pi, it means that it is in up to the two quadrants, first two quadrants, and that is why here sine always positive, and we will get here 0 to pi by 2, 0 to pi by 2 two times, and that is why result will be 2 times integration 0 to pi by 2 sin x raised to n dx, and we know the reduction formula for this. So for this also we can use reduction formula. Also you note that integration 0 to pi cos x raised to n dx equal to. Now again the same theory, that is 0 to pi by 2, 0 to pi by 2, 0 to pi. In the first quadrant cos positive, but in second quadrant cos negative. But if n is even, then I will get here positive value and I will get 2 times it. And that is why you remember this formula directly, that is integration 0 to pi by 2 cos x raised to n dx equal to 2 times 0 to pi by 2 cos x raised to n dx if n is even and equal to 0 if n is odd. If we consider integration from 0 to pi sin x raised to m into cos x raised to n dx, so definitely sine always positive, even though first quadrant, second quadrant, but problem with cos, and that is why here it will be, if this power is even, means cos power is even, then only it is a 2 times, otherwise it is a 0. So that is why that is equal to 2 times integration 0 to pi by 2 sin x raised to m into cos x raised to n dx if n is even, means it is a power of cos is even, and equal to 0 if power of cos, that is n, is odd. So we already have the reduction formulas for these. So directly we can find the reduction formulas for these or values of these things. If we extend up to 0 to 2 pi, means how many quadrants there? 4 quadrants there. Note that up to the 4 quadrants, every trigonometric function means sine, cos, tan, cosec, sec and cot 2 times positive and 2 times negative in different quadrant. So that is why here when we consider integration 0 to 2 pi sin x raised to n dx, it will be 4 times, but when n is even, means power of sine x, that is even, then only it is a 4 times integration 0 to pi by 2. If power is odd, then definitely 2 times positive and 2 times negative will get 0. So carefully go through these things. Similarly for the cos, integration 0 to 2 pi cos x raised to n dx equal to 4 times integration 0 to pi by 2 cos x raised to n dx if n is even and equal to 0 if n is odd. And also integration 0 to 2 pi sin x raised to m into cos x raised to n dx equal to 4 times integration 0 to pi by 2 sin x raised to m into cos x raised to n dx if m and n both are even, means here powers of cos and sine both are even, then only it is a 4 times, otherwise it is a 0 in other cases. It means that other 3 cases are there. If both odd, if m is odd, n is even, if m is even, n is odd. So in all remaining cases it is equal to 0. And one more additional thing is there, that is integration 0 to pi by 2 sin x raised to p into cos x dx, or same thing I can consider integration 0 to pi by 2 cos x raised to p into sin x. It means that if we consider sine and cos, so power of 1 should be 1 and remaining power whatever there, I am getting here 1 upon that power plus 1. It means that here power is p, so I am getting the result is 1 upon p plus 1. So when we are solving the examples, that time we have to use direct result. So that is why you must remember all these properties of the definite integral, even though this note as well as the reduction formula for sine, cos and multiplication of sine and cos. Let's consider some example on reduction formulas. Now by using this reduction formula, directly we can find out the values. For example, integration 0 to pi by 2 sine x raised to 7 dx. What is the value of this one? 0 to pi by 2 integration. So cos x raised to 8 dx. Integration 0 to pi by 2 sine x raised to 7 into cos x raised to 4 dx. Integration 0 to pi by 2 sine cube x into cos x raised to 5 dx. Also the integration from 0 to pi by 2 sine square x into cos x raised to 4 dx. So when we are solving such type of examples, we should have the standard result or deduction formula for sine, cos and multiplication of sine and cos. So by using that I can easily find out it. Here 7, so starting number in denominator is 7, then here 6, then 6 minus 2 it is a 4, minus 2 it is a 2. So last number is 2 or 1. So 7 minus 2 it is a 5, minus 2 it is a 3, minus 2 it is a 1 into, now the k power is 7 means odd, so I am getting 1. So what is value of this? So by using calculator I am getting the value is 16 by 35. Now here, so power cos x raised to 8, so power is 8, so here 8 and here 7 starting number. Then I can write here 5 into 3 into 1, here 8 into 6 into 4 into 2, and power is even, and that is why value of k is pi by 2. So solve by using calculator, so I am getting value is 35 pi by 256. Now here sine into cos, so powers here 7 and 4. So what is the addition 7 plus 4? So it's 11. So here I am getting 11 number. So 11 into then 9 into 7 into 5 into 3 into 1. But in numerator there are two different. So here 7 minus 1 I am getting 6 into 4 into 2. For this 4, so 4 minus 1 I am getting 3, minus 2 it is 1 into k. So if both are even, then only it is a pi by 2, otherwise it is a 1. So I am getting it's 1. So what is value of this? To simplify, so it is a 16 by 1155. So what about this value? So you solve and write your answer in comment box here. So addition is 6, so that is why starting number is 6 into 4 into 2, and in numerator 2 minus 1, so 1, and 4 minus 1, so starting number is 3 into 1, and into k, so both powers are even, that is why it is a pi by 2. So what is the answer here? It is a pi by 32. Now if we extend our limits from 0 to pi, so different example I am going to consider now here. Integration 0 to pi sine theta raised to 7 d theta, integration 0 to pi sine theta raised to 8 d theta, integration 0 to pi cos theta raised to 6 d theta, integration 0 to pi cos theta raised to 5 d theta, integration 0 to pi sine theta raised to 4 cos cube theta d theta, and integration 0 to pi sine cube theta into cos theta raised to 4 d theta. So as we know, the reduction formulas as well as the by using the note or properties of definite integral, I can write here 0 to pi. It means that two quadrants, and in both first and second quadrants sign positive, and that is why I am getting 2 times 0 to pi by 2 sine theta raised to 7 d theta. So 0 to pi, so two quadrants there, but sign in both quadrant positive, that is why it is a 2 times for any power of sine. So I can write here 2 times integration 0 to pi by 2 sine theta raised to 8 d theta. Here integration 0 to pi, so again two quadrant, but cos is positive in first quadrant, negative in second quadrant, but here cos theta raised to 6, even though negative but power is even, and that is why I am getting here positive positive, so it is a 2 times integration 0 to pi by 2 cos theta raised to 6 d theta. Here 0 to pi cos theta raised to 5. So 0 to pi, two quadrants, in second quadrant cos negative and power is odd, and that is why it is a 0. Directly value I am getting 0. So here 0 to pi. So 0 to pi, no problem about sine, but problem with cos. If power of cos is odd, then it is a 0 directly. And if power of cos is even, then it is a 2 times. And that is why I am getting the results as it is a 0, and it is a 2 times integration 0 to pi by 2 sine cube theta into cos theta raised to 4 d theta. Note that such type of MCQs also you can find in exam if MCQ pattern is there. So I am getting here 2 times, so you know the reduction formula. So you have supposed to be practice there. So I am directly getting here the values. So here starting number is 6, so 6 into 4 into 2, and here power is odd, so I am getting here 1. What is this value? So 32 by 35, you check calculation part. So here 2 into So 8 power is 8. So here 7. 7 into 5 into 3 into 1. Here 8 into 6 into 4 into 2. Power is even. That is why pi by 2. The answer is 35 pi by 128. You check always calculation part. If any mistake, you just put in comment box. So 2 into 6 here, here 5. So 5 into 3 into 1, here 6 into 4 into 2. Power is even, that is why pi by 2. So what is the answer for this? 5 pi by 16. I am getting answer. So it's a 0. It's a 0. What about this one? As we know by reduction formula. So answer is 2 into, here I am getting 7 into 5 into 3 into 1. And in numerator 3 minus 1 it is a 2 and 4 minus 1 it is a 3 into 1. Both are not even, that is why it is 1. So answer is 4 by 35. Similarly, same problem one can extend up to 0 to 2 pi. In the next video, we will continue this reduction formula with some different examples.